In this video, we'll discuss the basic unit vectors. These are the three famous vectors I, J, and K. Their components are 1 in the corresponding entry and 0 everywhere else. So I will have a 1 in the first entry, 0 everywhere else, and similarly for J and K. Notice it's customary, instead of a little arrow on top, to put what's called a circumflex or a hat on top. So we call this I hat, J hat, and K hat instead of an arrow. And that's to indicate that they are, in fact, unit vectors. If you take the length of I or the length of J or the length of K, they'll all equal a length or a magnitude of 1. Geometrically, you should think about these vectors as forming your coordinate system. So I runs parallel to the x-axis for 1 unit. If we're in standard position, J runs parallel to the y-axis, and K runs parallel to the z-axis. These three vectors sit at right angles to each other. Every vector in 3 dimensions can be written as what I will call a linear combination of I, J, and K. So if you give me a vector V, whose components are V1, V2, and V3, I can express it in terms of I, J, and K, and that way of expressing it is called a linear combination. In this case, V is going to be V1, its first component, times I, plus V2 times J, plus V3 times K. And I hope that's clear why that's the case. If you take V1 and multiply it by I, you'll have V1 in the first spot and 0 everywhere else, contributing that V1 in the first spot that you wanted it to be. This is just another way of writing your vector in component form. So V1, V2, V3 just corresponds to V1I, V2J, and V3K. So much so that we just call that first component of the vector, sometimes we'll refer to it as the I component of V. So V1 is the I component of your vector. And similarly, the second component is the J component, the third component is the K component. If we were working in vectors in 2 dimensions that didn't have a third component, we would just ignore the K component and we'd only have 2 entries. We'd have an I and a J component. So you're free to work with vectors in this bracket form or as a linear combination of I, J, and K. And just to illustrate how you might work and do the operations that we've discussed in this new way of writing things, I'm going to take the vector 2i minus 3j, and I'm going to subtract from that the vector 4i plus 2j minus k. Treat this algebraically, take any common terms or like terms and combine their coefficients, their components. So I look at the I components, I see 2i minus 4i of them. That means I'll have 2 minus 4 for the I component. I then look at J, I see minus 3, and I see minus 2 if I distribute that through, so I'll have minus 3 minus 2 times the J vector. So that's going to be the J component there. And then finally I have no K component in the first term, and I'm going to take away negative 1 times K, so that would be plus 0 minus 1 times K. And simplifying here, we have minus 2i, minus 5j, minus k. Again, this is nothing different than saying that these are the components of the vector, and you're welcome to write it in this form as well, in brackets, minus 2, minus 5, minus 1.